It is the time to play a game. The power cable goes to the power socket. The USB cable goes to USB port. The Ethernet cable goes to Ethernet port. And the fiber cable goes to where? There are multiple ways to connect a fiber optic cable into a network device. An Ethernet cable we connect to RJ45 connector to attach that into a network port or the Ethernet port. But in the case of fiber optic cable, it is totally different because fiber optic cable has multiple options for the connectivity. There are different types of fiber optic connectors and ports are available in the market. So in this chapter, we are going to talk about the fiber optic connectors and its interfaces. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 33, Fiber Optic Connectors and Interfaces. In this chapter, we will discuss about the fiber patch panel and how they used in networks. Then we will discuss about the copper and fiber cable characteristics. Then we will talk about different types of fiber connectors and interfaces that used in the industry. And finally, we will talk about the DAC cables. First of all, let's talk about the fiber patch panel. What is a fiber patch panel? You might have heard the word patch panel when we do the copper cabling. The concept of patch panel in the copper cable and the fiber cable are almost same. There is no difference. The only difference is in the connection types. That means the connectors and the ports that used in the copper patch panel and fiber patch panel are totally different, but their functions are same. So before we talk about the fiber patch panel, let's discuss about the copper patch panel, the normal patch panel. What is the function of a patch panel and why we use it in the network industry? To understand this concept, we can consider one network rack which is installed in MDF room. Then we have a server rack which is installed in the data center. So in the network rack, we can see few network switches that are used to provide the network connectivity to the devices. And in server rack, we can see lot of servers are hosted. The servers may be anything, maybe it's an application server or email server, a database server, or any storage server. So here our requirement is we need to connect all the server from the server rack into the network switches available in the network rack. So how we can make the connectivity in between these two devices? The simplest way is connect the cable directly from the network switch into the server so that the servers can access the network using the network switches. This is the simplest way. So do you see any problem in this kind of connections? In this scenario, there is no problem from the connection perspective, but there is a challenge for the administration. What is that challenge? Just imagine the distance between these two network rack is 50 meter. So how much meter cable we should use to connect these two network racks? Already the distance between two network rack is 50 meter. So we should use a network cable more than 50 meter to connect the servers and the switch. So just consider a 60 meter cable. The length of the cable is 60 meter. So when we use a 60 meter cable, we are able to connect the network switches into the server rack because the distance is 50 meter and just 10 meter we provided extra length. Because the cables are not connecting in a straight line, it is going in a different path to connect to the network interface that is available at backside of the server. So we need to consider a little bit extra length. So as per our scenario, we use 60 meter cable to connect all the servers into the network switch. Direct cable, direct server to network switch cable. Now let's assume a situation. Tomorrow, you need to relocate the server into a different place, which is 20 meter far away from the current location. So these servers are going to a different rack which is 20 meter away. So the total distance between two racks will become this 50 meter plus that 20 meter is equal to 70 meter. So are we able to manage the connectivity between these two racks? Because we have the total distance between two racks is 70 mm, but all of our cables are available only in 60 mm. So in that situation, we cannot use the same cable to make the network connectivity between the server and network switch because the length of the distance between two racks are higher than the length of the cable. So what we need to do in this situation? In this situation, we need to replace all the 60 meter cable and we need to use more lengthy cable. let's say an 80 meter cable. So when the distance is 70 meter, we can use an 80 meter cable to make the connections. So here we need to replace all of this cable. This is a challenge happening when we relocate the network rack or network switch or the server into a different location. So how we can overcome this kind of situation? It is not practical to replace all this cable, because all this cable may be going through above your ceiling or below the floor, and there may be going inside the trunking and a lot of cable tray, cable path, etc. So it is a very difficult job. So we can avoid this kind of situation by using a patch panel. Let's see how we can resolve this issue using a patch panel. So we can rearrange the network rack and server rack. We are going to install the patch panel in these racks. For that, I am going to install patch panel in both the rack. We have installed few patch panel in network rack. We have installed another few in the server rack. Now after the installation of the patch panel, we are going to the connectivity between these two patch panel with the help of Ethernet cable. So here each number from each row will be connected to the same row and same number in the other network rack. For example, in the network rack, we can number the patch panel as 1, 2, 3 and 4. And in server rack also we can number 1, 2, 3, 4. So when we do this Ethernet cabling, the cable coming from the first port in the first patch panel, that is this one, will be connected to the same port number 1 at the first patch panel at server rack. So in this way, 2 will be connected to port number 2, 3 will be connected to port number 3, and we will follow the same. Each patch panel port from the network rack will be connected to the same row, same number patch panel in the server rack, so that there will be connectivity between these two patch panel. So in this way, we will complete the wiring between these two patch panel. Then after that, we will connect the patch cable from the patch panel into the network switch in network rack. And in the server rack, we will connect the patch cable from the patch panel to the server. So they are getting connected. They are getting connectivity through the patch panel connection. So tomorrow, if all of this server need to move into a different location, then what we need to do? Do we need to change the complete wiring from network switch to the server? No, we only need to replace the patch panel of that server connected. So we need to replace this patch cable with a lengthy one if the server is moving to a different location. Same way, all of this patch cable we can replace with longer cable. Depends on the new location of the server rack. So this is the concept of using patch panel in the network industry. Now let's see what is a fiber patch panel. Fiber patch panel is nothing but it is a patch panel that we use to make the connectivity between the network racks. The only difference is instead of copper cable we will be using the fiber cable. In fiber patch panel you cannot see the Ethernet port anymore, and instead they will be using different ports and connector tapes to make the connectivity between the devices using the fiber cable. So how the wiring will be done between the fiber patch panels? Consider two patch panel which is located in two different network racks. To make the connectivity between these two fiber patch panel, we have to do the fiber wiring between them as shown in the picture. From each interface of left patch panel to the same interface of the right patch panel. So they are identified by numbering. Now let's see how the fiber patch panel helps to make the network connectivity. For that we are going to install the fiber patch panel in the network rack and the server rack. So in the network rack we have installed 3 patch panel, and in the server rack we have installed another 3 patch panel. Then same like the copper patch panel, we are going to make the connectivity between these two fiber patch panel using the fiber cable. And we made the connectivity. Now both the fiber patch panel are connected. Next step is, in copper patch panel, we were using the copper patch cable to give the uplink to the network device or the network switch. But here, instead of copper patch cable, we have to use the fiber patch cable. So we are going to connect the fiber patch cable at the network rack as shown in the picture. We can patch all the network switch into the patch panel. On the other side, from the server side, we can connect the patch cable into the fiber patch panel. So now all the server get network connection through the fiber patch panel because both the fiber patch panels are connected. There is a wiring between them. So in this way we can use the fiber patch panel in the network industry. Now let's see what is the difference between copper and fiber characteristic. To explain this, I am going to take an electrical characteristic diagram of a copper cable. So inside a copper cable there are 8 wires in different color in a twisted format. They are green, white, green, orange, white, blue, blue, white, orange, brown, white and brown. Total 8 wires. So inside a copper cable, this 8 wires has its own function. When we connect the network cable between two devices, these all wires perform their duties. That's why the connectivity is happening between these two devices. Now let's see what is the function of each wire. This green, white and green, they are using to transmit the data. As you can see, these wires are using to send the data. They transmit the data. This orange, white and this orange using to receive the data. So when we connect a cable between two devices, this green, white, green, orange, white, orange should be connected at both ends to occur the data transfer. If these two wires are faulty, then cable cannot transmit the data. On the other hand, if these two devices are faulty, then cable cannot receive the data. So these 4 wires are very important in an Ethernet cable. What about the other 4 cable? Still there are other 4 cables. And they are using for what? In normal network communication, they are not used. That's why it is mentioned unused. They are not using in normal network communication. But what is their function in an Ethernet cable? As you can see, the blue cable, you can see it is written DC plus. DC stands for direct current. It represents positive. And the blue white, it is mentioned DC minus. It represents negative charge. Again in the brown, we can see minus charge. In brown white we can see the plus charge. So when you see the plus and minus here, do you remember anything? What is the first point coming into your mind? It is the power. These 4 cable provide the power supply. So why do we need the power supply in Ethernet cable? There is a concept that is called PoE, which stands for Power over Ethernet. This concept is using to power up the network devices without any external power source. The power for that device can be delivered using the network switch with the help of Ethernet cable through these wires. So nowadays there are a lot of devices are available which support the power over Ethernet. The access point, the camera, the printer, etc. So we don't want to connect those devices into an external power source, then power it on, then again connect the network cable for the network connectivity. We don't want to do that thing. And instead we can just use a single Ethernet cable that can provide power and network connectivity at the same time. So we don't want to use an external power source. So these 4 cables, which are this one, is using to support the PoE function. That means the power over Ethernet for the networking devices. Now on the other hand, the fiber cable, they don't have this feature. They don't have this PoE feature. They are not able to provide the power into a device. So in fiber optic cable, there is only 2 cables available. One is used to transmit the data and another one is used to receive the data. Very simple, only 2 cables are available. As you can see, the picture shows a cross connected fiber cable. One side is transmit and receive. And at the other side, you can see this transmit cable connect in opposite way. So that means if there is a PC here, there is another PC here. Just imagine the top cable is using to data transmission and bottom cable is using to receive the data. So when this computer send the file using the transmit cable, it is reaching to the PC here at the receive side. So it receive the data. On the other hand, when the second PC send the data, it is using the transmit cable and receive it at the receive end. The data is accessible here. So it is not a transmit to transmit connectivity or receive to receive connectivity. Instead, it is cross connected, like transmit to receive and receive to transmit. Then only the devices can send and receive the data at both sides. So since 2 fiber cables are required to connect a single network connection, we need to consider 2 fiber interfaces for a single connection. So in this picture, if you can see, the first 2 cable is using for one connection. The second 2 cable is using for the second connection. So every 2 cable we can consider as a single network connection because it's need 2 fiber cable. One is for the transmission and the second one is for receiving the data. Now let's discuss about the different types of fiber connectors. What are the different types of fiber connectors? First of all, it is as per our requirement. We can decide the type of connectors and interfaces. So let's talk about the ST connector. What is ST connector? So ST stands for straight tip, because if you see the interface, you can see it is a straight tip, and it is a round plug and socket that lock with a half twist bayonet lock. So if you want to connect this fiber cable into this type of interfaces, you need to lock it by twisting it, because there is a lock, and when you twist it, that lock is activated, so the fiber cable can communicate with the interface in proper way. So this is the socket and this is the interface. Both the socket and interface is connected at the tip of the fiber cable, and then this connector insert into the interface and lock it by twisting. In that way the fiber connectivity can be implemented. And there are some caps available. Why do we want to use these caps? So in case if this interface is not using, there is no fiber cable connected or connector connected, there is a possibility that dust can accumulate inside the interface and it can affect the connectivity when we connect it later. So to avoid this kind of situation, these caps are used to protect the interface. This interface can be closed with the help of this cap so that dust will not go inside the interface. That is the function of these caps. Another type of connectors are SC connector. SC stands for square or standard connector, because here you can see this type of connectors are in square. This interface and connectors are in square. So that's why they are called square type connector or SC connector. And this square connector or SC connector, it is used as push-pull design but utilize a locking tab to secure the cable. So we can insert this connector directly into the socket, so it will be locked with a push-pull mechanism. And if you want to take out the connector again you need to push and pull so that it can come out easily. And SC is the most common fiber optic connector in use today and is typical for datacom and telecom application. Another type of connectors are FC connector. FC was the first optical fiber connector to use in ceramic ferrule. It utilizes a round screw type fitment made from a nickel plated or stainless steel. Another type of connectors are LC connectors, and this is the picture of LC connectors. LC connector nowadays very popular and we are using it very much in the network industry. This is most commonly using everywhere. LC stands for Lucent, Little or Local Connector. They designed as a push-pull connector that lock in the place with a latch to secure the cable. So when we insert this LC connector into the SFP, it is getting locked with a latch, and if you want to take it out, you can again use push and pull operation to take it out. It is half the size of SC connector. LC is now the preferred choice for high density connection. Since these LC connectors are very small, they are widely used. It is very easy to manage and size is half. They are in compatible size. So there are a lot of advantages for the LC connectors. Another type of connectors are MPO connectors. And this MPO stands for multi-fiber push-on. MPO can support up to 24 strand fiber. This makes the standard MPO cable ideal in environment where many fiber connection types are needed. So the MPO connectors are used in duplex fiber application throughout the data center to deploy pre-terminated plug and play backbone trunk cable between the active equipment. The one of the advantage of MPO connectors are they can carry up to 24 strand cable. So ideally they are very suitable for the data center cabling. Another type of connectors are ESCON connector, and ESCON stands for Enterprise System Connection. ESCON is created by IBM. Yes, so this is not created by Cisco or any fiber manufacturer. This is created by IBM, and ESCON are mainly used to connect mainframe computer to peripheral devices such as disk storage and tape devices. They are mainly used to create the network connectivity between the computers and the storage devices or media devices. Another type of connectors are MTRG connectors. MTRG stands for Mechanical Transfer Registered Jack, and they are the fiber optic cable connector popular with the small form factor devices due to its small size. As you can see in the picture, they are very small and thin. Another type of cable connectors are VF45 connectors. The VF45 plug-in socket work like an 8-pin modular jack, bringing the simplicity of the RJ45 jack into optical fiber application. So did you see the RJ45 jack? What is your opinion about the RJ45 jack? It is very simple. You can plug it easily and remove it easily. So that kind of plug and play simplicity is available with the fiber optic connection when we use the VF45 connectors. Now let's talk about the DAC cable. What is this DAC cable? The DAC stands for Direct Attached Cable. So before we talk about the DAC cable, we want to see how do we normally connect the fiber optic cable between two devices in traditional way. So just consider two network switches with SFP interface, and we use a fiber patch panel to connect between them. So here the switches are coming separately with the SFP interface, and the SFP modules are coming separately. Then the fiber patch cable are coming separately. When we connect all this together, we get the network connectivity. So on the other hand, the DAC cable is some kind of special cable in which the cable and the SFP module are attached together directly. So that means when this cable made, the manufacturer, they connect the fiber cable and SFP port together. It is not removable or replaceable. So what you need to do, just attach this SFP directly into the SFP interface of the network switch. No need to purchase the SFP module, fiber connectors and fiber cables separately. Just purchase a DAC cable and connect it. That's it. Your network connectivity is done. These DAC cables are mainly used inside the data center to provide the uplink between the different switches. This module will go to switch number 1 SFP interface, and the second SFP module will go to the switch number 2, so that there is an uplink between switch 1 and switch 2. So this is the concept of DAC cable. So in this chapter, we have talked about the fiber patch panel and how they used in network. We also talk about the copper and fiber cable characteristics. Then we have discussed about different types of fiber connectors that used in industry. And finally, we have talked about the DAC cable and how to use a DAC cable in the network. Thank you very much for watching the video. Please subscribe to the channel for more videos. Enhance your skills using iRash Academy.